Right. Welcome, folks. This time around is Form 2 Mathematics, and we're interested in sequence and functions. So let's have a look at things that we might find interesting in this discussion. We are going to be interested in things such as term-to-term rules, rules of a sequence, generating a sequence using the nth term, and also things that we might need to know as we get into this topic. That's prior knowledge, algebraic notation, basic number patterns, substitution. Then the objectives of this lesson, we are saying at the end of the session, you should be able to identify a term-to-term rule using numerical sequences, also description of sequence using words and simple algebraic rules, also generation of sequences from a given rule. We might also be interested in application of nth term of formula to find sequences in a term and also check patterns using substitution. So terms that we might be using in this discussion are sequence, term, term-to-term rule, pattern, nth term, arithmetic, sequence. So let's have a look at the following 10 problems and check if we can draw solutions. Right, the first problem, we're interested in finding the term-to-term rule of this given sequence. So first thing first, we look at difference between consecutive terms. For instance, 4 and 5, difference is 5, 9 and 14, 5. So it looks like this one is arithmetic. So we can say we are adding 5, starting with 4. So it's important to denote our starting point. Then moving on, we are interested in the rule. What are we doing to find the next term? So as we can see, we're starting with 100, 98, 70. So it looks like as we grow the term, we are subtracting 10, that's our rule. Or if you want, you can say minus 10 is the rule. Then moving on, identify the rule. What are we doing to draw the pattern? So if I can check there, this position is 1. So if I square 1, it looks like I get 1. But if I cube 1, whatever I raise 1 to a certain power, it gives us 1 still. But there, for the second position, 2, we are getting 8. And we know if we cube 2, it gives us 8. Third, we cube 3, 27. So here, what we are doing is we are taking the position n and we cube it. That's the rule. So we cube position. Generate the first 5 terms of a sequence where there is a condition. We are starting with 3, we add 5 all the time. So when we add 5, that gives us 8, 13, 18, and we put 3 dots to say it continues like that. Then write the first 4 terms of this sequence. We're given a formula there. So positions, they run in numerical form, that's in natural numbers. 4 times 1, so it means the first position we have a 4 and then followed by 2, then by 3, by 12, sorry. When we multiply 4 by 3, it gives us 12, then we have 16. Then we put 3 dots to say it continues like that. I've actually, well, that's the first 4 terms of this sequence. Write the first 5 terms of the sequence. So we are substituting into our formula. When the position is 1, it's 1 squared, it gives us 1. 2 squared, it gives us 4. 3 squared, it gives us 9. 4 squared, it gives us 16. 5 squared, it gives us 25. I'll put 3 dots to say it continues like that. Then moving to number 7, we are given a formula there to say if we want to find any term, we need the position plus 7. So here we're interested in position 7. So we are going to say term on position 12 is going to be where there's n, we replace it with the position. So it's 12 plus 7 gives us 19. So it means on position 12 we have 19. Find the sixth term of this given formula. So again, like we did, is T6. So where we have n, it becomes 6. So that's 5 times n, which is 6. So this will be 30. So it means on position 6, we have a number of value 30. Now we're given a formula there to say the nth term, that's Tn equal to 2n minus 1, where n is the position. So if we want term on 8th position, so 2 times 8, that's 16 minus 1, it gives us 15. So moving to number 10, list the first 5 terms of, so we are interested in 5 terms of that particular rule. So we know positions, they are in natural form, starting with 1. So 3 times 1, 3 plus 2, it gives us 5, followed by 3 times 2, that's 6 plus 2, 8. Then 3 times 3, that's 9 plus 2, 11. Then we check there, it looks like we are adding 3 all the while. So if I add 3 there, it gives me 14. 17. Then I put three dots to say it continues like that. I think that was it for the introduction to sequences and series. Let's meet in the second discussion. Bye.